Welcome to today's webinar. Today we are going to talk about automated document process. Before we start, we're going to introduce ourselves first. My name is Lily Fu. I'm a data scientist in Y Digital. In the past few years, I have worked with multiple clients on document processing and machine learning, also natural language processing. Today, I'm happy to share my experience in this field with you. Haiyan, can you introduce a bit about yourself?
Yes, thank you very much, Lily. I am also a data scientist at Y Digital. My name is Haiyan. I have a background in robotics, in control and AI, and I am specialized in machine learning, computer vision, and deep learning techniques.
Okay, come back to today's webinar. So today, we're first going to talk about challenges in the realm of document processing. And we're also going to take a close look at what kind of AI tools can help us in doing so. Later on, my colleague Haiyan will go through with you into some of the techniques that we use. And finally, we will conclude on this webinar. And during this session, if you have any questions or any remarks, please feel free to type it into the live chat session. And me and Haiyan will be happy to answer your questions from there. Okay, so let's first take a close look at the challenges. In the past few decades, many companies have gone through the path of digital transformation, or at least initialize such a path of digital transformation. However, sometimes maybe the results are not as pretty as one would expect. You would hope that this transformation can help your organization to become more efficient and effective in your daily process. However, sometimes it can go wrong. I have heard from so many clients that they complain about their data lake has now becoming a data swamp. That's not good news, of course. And sometimes digital information are becoming so fragmented that little islands are forming without even anybody noticing. Any of this will significantly slow down your business process, of course. So if your organization is familiar with any of these processes, you're at the right place. No, I don't mean that the process is at the right place. I mean today you're at the right webinar. Hope you could learn something from our experience as well. And if none of this sounds familiar for you, don't worry. You're also at the right place because now you can actually learn from people's experiences and hopefully preventing your organization to go into such a path. Okay, let's now take a closer look at each of the problems that you might encounter. So the first one is this search problem. I know many companies use so many different platforms for people to document and to share their knowledge, which is actually a very good practice. But in reality, when you want to look for some information back, and you might need to go through multiple channels and back and forth. And that, of course, itself wastes so much time. Let's say if one person in one company is searching via 5 different platforms, and that takes about 5 minutes. It's not a big amount of time. And let's imagine if you are a company of 100 people, and that would be 500 minutes. And this itself is already approximately 8 hours. And that means 1 FTE is wasted just on searching itself. Imagine if you can have a platform that can help you to connect all of the data sources that you have, internal and external. If people can just go into one UI and type what they want to know, and all the results come together to you. How nice would that be? And of course, when we're talking about search, we're not talking about some very maybe simple, or you can even call it stupid search. So sometimes users make typos, right? And your search results, you don't want it to reflect the typo results. And even better, sometimes your source documents can contain typos. You also don't want those information to come back. An intelligent search system should be able to understand what the user intends to look for, the semantic meaning of the search query, instead of the literal words of the typed search. So it should be able to allow you to search on fuzzy matches or even synonyms, compounds, or just the stem of the words. And another problem that an organization might face with is the relation extraction problem. And let's say a domain expert, when they're processing certain documents, they can easily see links between the documents and maybe classify documents on the go. However, with such a large amount of information in place, even a domain expert cannot compete with, let's say, a trained computer node that are targeted in solving such issues. And on this picture, you can actually see that this is one of the knowledge graph that we have generated for a real client. And here, all the business entities, our relations, are represented in a very nice format. Isn't this beautiful? Okay, so up to this point, we have been talking about an integrated system. And you might have the question, okay, what about security? What if not all users are supposed to see everything? And of course, this is a very common thing in large organizations. And therefore, we're actually proposing a role-based, document-based access search system. In this system, different people will be assigned different roles based on the projects, for example. And in this example, we see when John does a search, he finds 3 hits. And when Jen does her search, however, she gets 5 hits. Not because we like Jen more than John, it's only because for this project, Jen has more access, her role has more access towards this document. And let's say if Jen moves to a different project later on, her role will remain, and Amy will replace her in such project. Amy will have the same search results. Another pain point in document processing is document versioning. I think maybe every of us can relate to this problem to some extent, maybe some more than others. So it could be that you worked with one document in one place. Let's say you have drafted a letter and you saved it to your OneDrive, and later on you edited it a bit more, and then you shared this document with one of your colleagues. And on the company level, maybe there are other information added later, and then you share it with the whole organization in your SharePoint. But later on, when you want to look back to find the exact version you want, it's not an easy peasy thing anymore. Imagine if you have such a UI which can illustrate you and highlights the differences between the same documents and in different sources. This will make our life so much more easier. So in big organizations, most often a team will work together on one single document. And over time, this document has changed. Different people have made different edits. This, again, is a disaster if you want to find the right information. Here we propose a feature that can be quite useful to you and your organization. That is this timeline feature. So in this nice illustration, you can see the development of your document over time and easily find out who has done what at what time. Not only information of the author and the timeline is important. The content, of course, is the wisdom of the document, which is also very important. Maybe you have used the Facebook share photo function where you can upload a picture and automatically all your friends are tagged within that picture. If we can have such a functionality to a document, how nice could that be? Imagine you no longer need to go through the seas of the document and find the exact category you want. This tool can automatically help you to tag out the category of this information and also share with other people. So in automated tagging system, of course, it won't, your algorithm or your tool won't be perfect from the beginning, or different organizations might have different type of schema that they want to use. This is not a problem at all because we always include the user into the loop, which means the user can easily change the text of the document. So if the system thinks, okay, this maybe is a meeting note, and you want to correct for it, you say, no, actually, this belongs to the category of legal system, let's say. And over time, our tool can learn from your changes, from your edits. And the user input is actually quite essential to this tool in making itself smarter and evolving over time. Up to this point, we have talked about some quite basic features that can be used in automated document processing. Maybe you wonder, can AI help me even more? Can it be even more smart in help with my process? Okay, let's say if your job is to go through different reports, those reports can be quite lengthy most of the times. You have to view 20 pages, 10 documents per day. That itself is very overwhelming and time-consuming. Can AI help in this? Yes. So with our trained model, we can actually extract relative information from your documents and summarize them together, put them into a one-pager, which allows you to view the lengthy document very efficiently. Okay, I have talked about a lot of nice features now, and you may wonder, all of this, are they black magic, or how do we actually make this work? In the next session, my colleague Hai-En will uncover some of the underlying AI techniques that may be used for your organization or even other applications. Okay, Hai-En, the floor is all yours.
Yes, thank you very much, Lily. So we have seen how a integrated semantic search and automated document processing pipeline can alleviate the headache and also the manual labor that is involved in processing and in structuring a document-rich environment. And now we will change our focus slightly. We will dive deeper into the techniques that actually allow us to extract data from all kinds of data sources and build the data foundation and also enrich the data foundation that allow us to create this whole data pipeline and bring value to the end user. We will do so by focusing on two main pillars of artificial intelligence, namely computer vision and natural language processing, NLP. And these techniques essentially replicate our power as human beings, namely the perception and also the ability to process language and analyze them through the use of algorithms. Computer vision is essentially, as mentioned, the replication of our perception ability to analyze images and videos. The first technique we want to focus on is OCR. It is probably one of the most primitive and well-studied topics in computer vision. It stands for optical character recognition. Probably, Lily, you have also seen this being applied in the real world. You have, I assumed, been at parking lots, PNRs, where you don't have to manually check in, but you can just stand at the port. It will open, check your license plate, and when you go out, you don't have to go to a certain machine to pay, but it will recognize again your license plate, and then you have to pay a certain fee based on the length of time that you have been in that parking spot. This same technique can also be applied to address the issues that you have mentioned, So extracting data from all types of documents. This could be invoices, as we see here. This could be IDs, legal documents. So we can actually extract text from all types of documents and use this data as metadata, as data that can be searched on through fuzzy searching. And this would allow us to easily find the documents that we need and also find them in groups of documents. And again, that would allow us to check for versions of certain documents, etc., etc. Another technique we want to focus on is object detection and object segmentation. What this refers to is essentially recognizing or extracting certain objects within an image or video. So for example, if we look around, we see, oh, that is a person, that is a cat, that is a dog. And we want to algorithmically build this ability that would allow us to automatically extract this information from, for example, documents, from images, and then automatically process and build the data for our search functionality. We see this once again in the real world. It's very, very popular actually, especially in the field of robotics and autonomous driving. Tesla's, Google are putting a lot of investments in developing this technology and making it possible to actually bring value to the end user. But not only is it applicable in the field of autonomous driving and robotics, it is also applicable in, for example, agriculture. Or what we see here is an example of a project we did with a previous customer, where we apply object detection algorithms to detect faulty packages within a sorting conveyor belt system. So the possibilities are basically endless. We would feed a system with a lot of samples of certain objects and train the model such that it can actually take out and extract the characteristics of certain objects. And when we put this model into production, it would be able to extract and detect the object that we're looking for. And on a document level, the same idea implies. We can train a certain model. For example, in this use case, we can train the model to detect labels from technical drawings. This could be, for example, an engineering company that has many different types, different versions of technical drawings. And we would like to extract the labels from technical drawings, where, of course, most of the information about the project, where it is, what it is about, is encapsulated. And we can then, for example, use the technique of OCR to extract text-based information from this label and, again, use it as a searchable content for the end user. And it could also be used as, for example, a preview for the search functionality. Another use case for this could be in security region, where to conform to certain privacy requirements, we would want to actually detect, for example, BSN numbers, so citizen number, and could be also the profile picture that is on your driver's license or on your ID. And then we could integrate that with, for example, a role-based access control system, and only allow certain users to access information, that is supposedly private, while others will not have the same access. And finally, image classification. Image classification is also quite a well-known topic within computer vision. Probably you also know the classic example of dogs and cats classifiers, where we feed thousands and tens of thousands of images of cats and dogs, all different species, all different breeds, different facial expressions, to a certain model that would allow it to find the characteristics of the two species and kind of be able to split them apart, such that when we deploy the same model, it would be able to say, this is a cat, rather than thinking that it is a dog, even if it kind of looks like it. And the same idea, again, holds for document processing. We could train a model such that, in this case, it will not classify between dogs and cats, I hope, but it will be able to, for example, distinguish between technical drawings from scanned receipts, invoices, and, for example, legal documents, right? And yeah, this would allow us to automatically go through different types of documents that we have, rather than putting the manual labor in and spending this time to actually manually process and digitalize the document system. And yeah, as you may imagine, we have seen now 3 different computer vision techniques. They can be used and applied separately, but also in combination. And yeah, again, the realm of applications and real-world applications are pretty much endless. It could be used in medical imaging. We could perhaps use it to check for faulty claims of insurance, but also in the field of e-commerce and many more, essentially. And computer vision or perception is not our only power as human beings. We as humans also possess the ability to read, listen, and analyze and understand text. And this is also what we want to bring back in our system. Natural language processing is something that replicates our ability to process text, different forms of text. And text classification is one of these techniques. When you read a document, when you see a document, you can, at one instinct, distinguish between, for example, this is an invoice and this is a Word document that is describing a certain product. And what we want is to replicate this algorithmically, right? And essentially it is extracting the key features of certain text that would allow us to distinguish between these types of text. And this can be used also in combination with image classification, for example, or with OCR, where we extract text from images, from scanned documents, and then perform text classification to distinguish between these different types of text. And while text classification needs predefined labels, it needs prior knowledge, a lot of prior knowledge about the documents that we have, the types of documents that we have. This, in reality, is not always the case, right? So through metadata extraction, we would be able to extract data from various types of documents, once again, and cluster them based on similarities. And this, of course, is a bottom-up approach where we would be able to bring value to the end user even without a lot of prior knowledge. And finally, a technique that we want to focus on is automated summarization. I think you've already mentioned this before. You could be confronted with documents that are tens, maybe hundreds, thousands of pages long. And this, for the end user, is very difficult to actually grasp whether he or she has found the document that he or she was looking for. So through algorithms, we could extract summaries from these types of documents and present it such that the end user, at one glance could understand what the text is about and actually, verify at that moment whether he or she has found indeed the correct document that they're looking for. So, all in all, I think we have shown a lot of possibilities today. We have shown that AI techniques could be integrated with a system that has role-based access control capabilities, semantic search capabilities, linked data capabilities, and many more. With all these techniques and features in our toolbox, we could create modular solutions based on specific business needs that would allow one to automatically create a data processing pipeline that would cut down all the messiness, the chaotic processing steps that you were mentioning in the beginning. And it also cuts down the manual labor that is involved in analyzing and processing all these documents. Once again, the possibilities are endless. The applications of these techniques and features can be applied to many different fields, and the developments in all these different fields actually bring back useful information and useful abstractions that would also allow one to optimize their own system based on knowledge that has been built by someone else. And I think this is something that also is fundamental about AI, that it is developing very quickly, and many people are using it to develop their own solutions for their own needs. And that in turn would help you to develop your own systems, because it brings ideas and it brings also techniques that would allow you to optimize your own system. If you have any business ideas, needs, or discussions, inspirations you want to get, or projects you want to talk about after this webinar, feel free to contact us at result@wired.digital.
Thanks for watching this webinar and go through with all the challenges in document processing and all the techniques that can be applied in automate your document processing process with us. And we hope to see you in more of our webinars of Wired Digital in the future. Thanks.